So we have a conundrum. We know that when price increases, the total expenditure or the total revenue, which we can just abbreviate by TR, is either going to do three things. Either going to increase, it's going to decrease, or it's going to stay the same. Which path it goes on, that is determined by, depends on, it's determined by the elasticity. So our total revenue or our total expenditure is going to be defined as our price times our quantity. So let's go ahead and do an example. Let's talk about movie tickets. So let's say that, we're talking about 10, 15 years ago, right? And we're talking about movie ticket prices increasing from $2, and that was a long time ago, to $4. How much does it cost to go to the movie here in town? Like $6 or something like that, right? It's not that bad. 7? Yeah. 7.5, something like that. Yeah. So even with our discounted remote location, this is still not accurate in terms of what's going on. But just for the sake of argument, we're just gonna agree. Okay. So we're gonna call this point B, and we're gonna call this point A. And we are given some information about movies. We are given a demand schedule. And we are told that at this particular point A, there is 500 tickets being demanded at the $2 price. So if we were to create a rectangle that represents the area of total revenue, it would look like this, right? Total revenue is equal to price times quantity, which means it's going to equal 2 times 500, which means this whole thing is going to be $1,000 of total revenue. Questions on that? On our total revenue calculations? Oh my gosh, will you please erase? Thank you. Things to do on that side. Come on. Now, what happens if the price increases? We are told information that both of these points, both this $2 price point and this $4 price point, right? We're given this information that both A and B are below the midpoint on the curve. Cool, Dr. McCarthy. Why do I care? Well, you care because the midpoint on the curve tells us something about the elasticity, right? So just for a second to take your attention away from what we're currently writing on, if we go up here, the midpoint of the curve is where elasticity is equal to 1. So anything that's below the midpoint of the curve is going to be in the what range of the curve? Inelastic range. Very good. When the elasticity is less than 1, it's inelastic. So this is going to be in the inelastic range of the curve. That's what this is telling me. So what we learn in this chapter, and what I'm going to show you graphically and mathematically, is that when we're in an inelastic range, a price increase is going to result in a total revenue increase. My box was too large. My spoon was too big. You guys probably don't even remember those cartoons. Old classic cartoons. Probably not even funny anymore. So we know that the total revenue is going to go up because we're in an inelastic range and we're increasing the price from $2 to $4. Let's go ahead and show it to ourselves. Why not? That's why we're here, to prove to ourselves the things that they tell us in the book. So at point B, at $4, we now sell more or less than 500. Less. Law of demand, right? Higher price, always going to be less. So the book tells us, the prompt tells us, that we now sell 400 tickets. What is my new total revenue rectangle? Is it greater or less than 1,000? Our theory says it should be greater. Let's check. Let's make sure it is. Total revenue is equal to price times quantity, which is going to equal 4 times 400. 4 times 400 is 1,600, which, you betcha, is greater than 1,000. Therefore, my total revenue did increase just as expected from a price increase in an inelastic range of the demand curve. To cement things in, I'll try to go as quickly as possible, but let's talk about the elastic portion of the demand curve and what's going to happen. For those of you that got A's in logic, you can figure out that a price increase in the elastic portion of the demand curve is going to do something different. In fact, it's going to lower total revenue. So let's go ahead and do that example real quick. So this is kind of movie tickets part 2. So now we are told that the ticket prices have gone from $8 to $10. And we're told that both of these prices, actually let's not do A and B because that's going to be confusing. Let's do C and D. Both C and D are above the midpoint. To our well-trained economist ears, we know that above the midpoint is just econ speak for telling me that we're in the elastic portion of the demand curve where the elasticity is greater than 1. So let's go ahead and do similar graphical analysis as before. Let's see how quick I can do it. Price, quantity, demand curve, that should be straight line. We have a price of 8 and a 200 tickets, and we've got a price of 10 and 100 tickets. So now we're going to go ahead and do that same total revenue rectangle. Now it's just you just flip the Tetris block from being long ways to looking like a office building now, right? But it's still the same total revenue rectangle that we're making. Total revenue is equal to price times quantity equal to 8 times 200, which is going to be what? 1,600. Compared to when we increase the price to $10, we end up getting even skinnier of a Tetris block, or I should probably say Minecraft block or something, I don't know. So 10 times 100, right? Total revenue. Ten of hundreds is 1,000. And so what did we see here? We saw total revenue decrease. And this is because when the elasticity is greater than 1, any increase in the price is going to result in a decrease in the total revenue. Questions on that? Cool. I'm very proud of you all for getting through that. A lot of head nods, a lot of eye contact. That's good. That's probably some of the more like heady kind of stuff that we're going to be doing in this micro class. So it's a very good sign. Very promising. Okay, let's move on to some more definitional stuff. Oh, let's pause our notes, right? We're